Good morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Vinda with another video. And now we are continuing on a calculus 1. This is the product rule. Example 1. We have two questions, number 1 and number 2. In this video, we are going to answer question 1, which reads, find dy dx if a, y is equal to square root of x multiplied by 2x plus a 1 raised to the power of 3. B, y is equal to x squared multiplied by x squared minus 2x raised to the power 4. So we are just simply going to write solution. Okay. Then after writing solution, we get on with the answering, which is A, we have y is equal to square root of x multiplied by 2x plus a 1 raised to the power 3. We'll say let u be equal to square root of x, v be equal to 2x plus a 1 raised to the power 3. And then u can also be written as x to the power 1 over 2. And then let's just write v again, which is 2x plus a 1 raised to the power 3. What have I done? This is the law of indices. The root is the denominator down there. But for the square root, we do not write the denominator. So here there is an invisible 2. But for the cube root, for example, if we were to write 8 raised to the power 1 over 3, it's the same as writing cube root of 8. Why we write the 3 there, and then we say multiply it by the numerator there, which is a 1, which is just cube root of 8, like that. Okay, so to continue, we differentiate these two separately. We are going to have du x is equal to 1 over 2 x raised to the power negative half, and then dv dx is equal to 3 multiplied by 2x plus a 1 raised to the power 2. Then the derivative of the core is a positive 2. So we're going to have is equal to 1 over 2 x to the power negative half, and then dv dx is equal to a 6 multiplied by a 2x plus a 1 raised to the power 2. And then if you want, you can write this du dx to be equal to 1 over 2 square root of x. And then we have du dx is equal to that, dv dx is equal to that. Okay, then to continue, we're going to say dy dx is going to be equal to u dv dx plus a v du dx. So this formula, what is it? This is a formula for when you want to find the derivative of the multiplication of two functions, okay? This is the formula we use. So is equal to, the u that we have is root of x, and then dv dx is this one underlined there, which is multiplied by 6 multiplied by 2x plus a 1 raised to the power 2, like that, then plus a v. The v is a 2x plus a 1 raised to the power 3, and then the du dx is this which we found here, which is multiplied by 1 over 2 root x, like that. I hope you can see that. And then to continue, this is going to become is equal to 6 multiplied by square root of x multiplied by 2 plus a 1 raised to the power 2 plus a 1 over 2 root x, like that, multiplied by 2x plus a 1 raised to the power 3. And then what is common here, if you look nicely, the square root of x is common, but we cannot factor it out completely. Alright, it would be pretty difficult to factor out the root of x. Okay, So we look at 2x plus a 1. 2x plus a 1 is common. Now 2x plus a 1 raised to the power 2 is smaller than 2x plus a 1 raised to the power 3. So we're going to factor out 2x plus a 1 raised to the power 2. So the final answer will be dy dx is equal to what? We have 2x plus a 1 like that raised to the power 2, then multiplied by 6 root x like that, plus a 1 over 2 root x multiplied by a 2x plus a 1. There it will be raised to the power 1 simply because we have factored out this amount, which is power 2. Power 2, because this is 2x plus a 1, this is 2x plus a 1, same base. Okay, when you're multiplying same bases, you add the power, so it's still giving us power 3. So this answer like this would be your final answer. That's how we'd find the product rule for this question. Thank you so much for watching. This is the solution for question A. This has been Cornelius Subinda with another video. I hope you can see what I did. Let me just show you. Yeah, that's what I did. Sorry for not showing that part. But this has been Cornelius Subinda with another video, and bye-bye.